Hi, Assalamualaikum and good day to my Dahabsa and all my fellow classmates. We, as the last group to present, would like to enlighten everyone on one of the C6 aromatic petrochemical, which is Phthalic Anhydride. I will introduce you my group members, Nurdiana Shaira, Nurul Afifah, Ashraf, Hanis and Ismahani.
Hi everyone, Assalamualaikum and good day. My name is Ismahani. So before I kickstart my presentation, I hope everyone is in a pink of health during this pandemic. Take care and stay safe.
So first of all, I would like to ask you guys, do you know what is phthalic anhydrides? Phthalic anhydride produced for typical of those intermediate synthetic organics which has formula C6H4CO2O that used in the manufacture of many consumer products such as plasticizers, polyesters and alkyd resins. It also can be used in the production of paints, plastics and synthetic resins. Phthalic anhydride is a colorless crystalline organic solid which on hydrolysis forms the aromatic O-benzene dicarboxylic acid. It can produce by three processes. First, catalytic gas phase oxidation of xylene. Second one is the vapor phase oxidation of naphthalene. And the third one is simple thermal dehydration of phthalic acids.
Next, the end product of phthalic anhydrides: wire and cable application, coated fabrics, roofing membranes, swimming pool liners, dye intermediates, food preservatives, insect repellents and also perfume fixatives.
Assalamualaikum, my name is Afifah and I'm going to present about the reaction and mechanism of phthalic anhydride. Phthalic anhydride is well known as a versatile intermediate in organic chemistry owing to its bifunctional and availability in the current market. The phthalic anhydride can either be produced from catalytic oxidation of O-xylene or catalytic oxidation of naphthalene. The catalytic oxidation of O-xylene is much more preferable as its feedstock is much more cheaper and the yield percentage is higher compared to the catalytic oxidation of naphthalene. The catalyst used for both reactions is vanadium pentoxide. Basically, there are three ways of producing phthalic anhydride, which is first, catalytic oxidation of naphthalene, second, catalytic oxidation of O-xylene, and lastly, thermal dehydration of phthalic acid. First, catalytic oxidation of naphthalene. The reaction temperature and pressure involved is between 325 degrees Celsius under 1 atm of pressure. This modern industry currently use gas phase vanadium pentoxide as a catalyst in the catalytic oxidation of naphthalene. The second reaction of producing phthalic anhydride is catalytic oxidation of O-xylene. The reaction temperature and pressure involved is between 325 degrees Celsius to 400 degrees Celsius under 1 atm of pressure. The selectivity of this reaction is up to 70% and it also produces byproduct about 10% of maleic anhydride. The last method of producing phthalic anhydride is simple thermal dehydration of phthalic acid. This reaction involves hydrolysis by using hot water to produce phthalic acid. Usually, this reaction is not a reversible process. However, the phthalic acid is rapidly dehydrated to form phthalic anhydride and it is reformed above 180 degrees Celsius.
Hi everyone, Assalamualaikum to Madam Habsha and my fellow classmates. My name is Nurdiana Shaira and I will be presenting on the catalyst part for the production of phthalic anhydride. I hope you guys are in a good health and please do take care of yourself during this pandemic and stay safe. I hope you guys understand on the reaction and mechanism that is already presented by Afifah. So I will proceed with the catalyst use. First of all, what is catalyst? Catalyst is a substance that promotes and enables a chemical reaction to proceed at a usually faster rate. Some of the catalysts that is widely and commercially being used for the production of phthalic anhydride in the oxidation of O-xylene is vanadium pentoxide supported on anatase, which shows superior behavior. A high activity and selectivity of the catalyst is achieved when the catalyst is present in a highly dispersed amorphous species rather than the crystallite form. So the liquid phase of the catalyst is actually better than the crystallite form of the catalyst. And it was shown that the increase in the content of vanadium, which is in the range of 1% to 12%, has little effect and may result in a slightly low performance. This is in agreement with the higher performances attributed to the monolayer catalyst obtained when the amount of active oxide deposited on the surface of the supporting oxide correspond formally to a single dimensional bilayer. So let's proceed to the characteristic of the catalyst. The table beside is the characteristic of the catalyst where it operates at an optimal condition. So let's go through the table one by one. The active phase of the catalyst is in between 2 to 15%, which show high performance. The thickness of catalytic coverage covers for about 0.05 to 1.5 millimeters, supported on anthase or quartz. The dimension of the catalyst, the diameter is between 4 to 12 millimeters, while the height is in between 6 to 12 millimeters. What I wanted to highlight here is that the characteristic of the catalyst plays an important role where the role of the parameters such as the surface structure and morphology of the anthase, grains, the composition of the gas phase, and kinetics of the surface migration has been studied to have some insight into the mechanism of the spreading of the active element over anthase. So the characteristic of the catalyst actually plays an important role to the process. And additional info to add on, some of the process might add a promoter in the process, where an on-purpose study have been conducted to show that when adding a promoter, we can increase the rates of reaction, yield, and selectivity. Some of the promoters that can be used is either an elemental bromine or a bromine compound which is capable of dissociation into an elemental bromine. So why do we add a promoter? The reasons why a promoter is being added is to achieve a high rates of reaction, yield, and selectivity. Also, a bromine promoter is effective to selectively activate in the vapor phase of the methyl groups and thereby increase the rate of selective oxidation. Another one is that it permits a lower reaction temperatures and reduce the production of undesired partial oxidation products. So when you add a promoter, we can actually increase the selectivity, increase the yield, rates of reaction, and also reduce the formation of byproducts.
I will present about the process flow diagram of the production of phthalic anhydride by catalytic oxidation. Back to our production plant, we have two raw materials, which is air and autosilane. Both of these raw material will undergo the catalytic oxidation in the reactor. From the reactor, the product of the reactor will go to the separator to separate between gas and liquid phase. Most of the desired component will remain in our liquid phase, and the gas phase of the separator will go to gas treatment. And then from the bottom product of the separator liquid, we undergo to distillation unit for further purification. In the first distillation unit, we try to remove the vapor and the unwanted gas in the first distillation unit, while the bottom product from the first distillation unit, we undergo to further purification to obtain the maleic anhydride and phthalic anhydride. Maleic anhydride will be a top product of this second distillation unit, while phthalic anhydride could be at bottom product because it is much higher boiling point compared to maleic anhydride. Both of these components can be sold in the market.
For safety measures, there are three common hazard identification symbols associated with phthalic anhydride. There are corrosive symbol, haphazard symbol, and the third one is irritant symbol. Phthalic anhydride may form combustible dust concentrations in air, harmful if swallowed, can cause skin irritation, can cause serious eye damage, it may cause allergy or asthma symptoms or breathing difficulties if inhaled, and it also may cause an allergic skin reaction, and it may cause respiratory irritation. For accidental release measures, we have divided into two common categories, that is small spill and large spill. For small spill, it is required to use appropriate tools to put the spill solid in a convenient waste disposal container. And for large spill, it is required to stop the leak if it without risk. Do not get the water inside the container, do not touch spill material, and also use water spray to reduce the vapor. For handling of phthalic anhydride, it is suggested to use only under a chemical fume hood. Wear personal protective equipment or face protection. Do not breathe the dust, vapor, mist or gas. Do not get the phthalic anhydride in the eyes, skin or on clothing. Do not ingest the phthalic anhydride. If swallowed, then seek immediate medical assistance, and also protect it from moisture. While for storage of phthalic anhydride, it is required to keep the containers tightly closed in a dry, cool and well-ventilated place. Also protect it from moisture. For first aid measures of phthalic anhydride, first of all, if phthalic anhydride get into the eyes, it is required to rinse cautiously with water for several minutes. Remove contact lenses if it is present and easy to do. Second, if phthalic anhydride is inhaled, remove the victim to fresh air and keep at rest in a position comfortable for breathing. And the third one, if phthalic anhydride come in contact with skin, it is required to wash with plenty of soap and water. Take off the contaminated clothing and wash before use. Finally, if phthalic anhydride is ingested, do not induce vomiting unless it is directed to do so. Never give anything by mouth to an unconscious person. There are some engineering measures that are suggested in handling phthalic anhydride. First, use only under a chemical fume hood. Second, make sure that the eye wash station and safety showers are close to the workstation location. For personal protective equipment, we have divided it into two main categories. That is first, personal protection, and second is personal protection in case of large spill. For first, personal protective equipment, it is really recommended to wear protective eyeglasses or chemical safety goggles. Second, wear protective gloves and clothing to prevent skin exposure. Next is wear a suitable respirator such as vapor or dust respirator. And finally, it is really recommended to follow a good industrial hygiene and safety practice. For the second one, for personal protection in case of large spill, it is really recommended to wear splash goggles, wear protective gloves and synthetic apron. Next is suitable respirators such as vapor or dust respirator. And finally, boots and must follow safety practice.
I will explain about the additional information of phthalic anhydride. As you can see from the pie chart, the major consumer of phthalic anhydride is come from the mainland China, and 57% of the phthalic anhydride is being used in the plasticizer. Generally, plasticizer is a solvent which is used to promote the flexibility and the plasticity of a substance. Phthalic anhydride is also being used in our daily life. For example, the production of plastic from vinyl chloride. Other than that, phthalic ester is also used as a plasticizer, which is derived from the phthalic anhydride. Lastly, phthalic anhydride is used to produce alkyd resin in the production of paints and lacquer.
Hi, it's me again. So I will discuss on the sustainability, and I have found 4 important points that have been taken into consideration to promote sustainability in the production of phthalic anhydride. One of them is that they use other processes. Instead of using the already available and commercial process of oxidation of oxylene, they substitute it with another process which use another raw material, which is hydrogen peroxide, where the process is either hydrosylation of phenol, the epoxidation of propene, and also maximization of cyclohexanone. Many researchers that have been conducted in making the production of phthalic anhydride sustainable in terms of its cost, efficiency, and environmental effect, they also use new type of catalyst. the development of a new types of heterogeneous catalytic systems for liquid phase oxidation and the use of an environmentally friendly oxidant. These, for example, they use hydrogen peroxide and air, which in place of hydroperoxides leading to the co-formation of sizable amounts of co-products. So they use a new type of catalyst to reduce the formation of byproducts. The next one will be the synthesis of intermediates and monomers from alkenes. Oxidative processes occurs by replacing the traditional synthetic pathway for alkane from aromatics. And this has implied not only economic advantages with respect to technologies, but also the replacement of either toxic reactants and intermediates or multi-step processes. So when they use substitute with intermediates or monomers, it actually can promote lesser byproducts in the process. Okay? Last but not least, they use the shift from air-based once-through processes to a more selective and less polluting oxygen-based recycle. And also it is an environmental friendly. This has led to a lower emissions and reduced costs for treatment or disposal of contaminated streams, which more than compensate for the higher cost of compared to oxygen.
Production of phthalic anhydride by using catalytic oxidation of xylene produce waste such as excess gas, unreacted phthalic anhydride, malic anhydride, organic acids and also wastewater. For liquid waste management, most liquid waste streams are sent to on-site incinerator. Wastewater sent off-site, first by using cooling tower blowdown, second distillation vacuum jet condensate, and the third one steam boiler blowdown. For solid waste management, consists primarily of residue and heavy ends removed during product pretreatment and distillation. Light and heavy ends rejected in product distillation are sent off-site for disposal. For main process vent gas, consists of the gross reactor effluent after cooling and recovery of crude phthalic anhydride. It's sent to a water scrubber or an incinerator for removal of hydrocarbons and other pollutants. For pretreatment and product fractionation vents, effluent water from steam jet ejector sent to main process vent scrubber. Effluent believed to be sent to incinerator. Next, wastewater that condensate in a hot well is sent to the sewer. Exhaust steam from ejectors sent to waste product thermal incinerator, while exhaust steam vented to atmosphere. For waste product incineration, impurities removed in product distillation facilities are either sent to the main process vent incinerator or a separate incinerator for waste products. For feedstock storage vents, xylene feed is stored at ambient temperature in fixed roof storage tank. Low vapor pressure hydrocarbon emission from this source are small. For product storage vent stream is permitted to cool for knockout of solid phthalic anhydride prior to atmospheric venting. The product storage tanks vent to atmosphere. For crude phthalic anhydride, storage tanks are vented to waste product incinerator. Vents from all product storage tanks are collected by an ejector and burned in main process vent incinerator. Okay, let's move to the other one. For flanker and bagging exhaust, phthalic anhydride product is stored and transported as a liquid. Occasionally, the product is shipped as a solid. Air emission of phthalic anhydride from the flanker and bagging operation are small. Lastly, for heat transfer fluids, there is only a small amount of hydrocarbon emissions result from vents of such tank in the switch, condenser, heat transfer oil circuits.
Next, there is some environmental issues that relate to the production plant of the phthalic anhydride, which is the first is the potential of the air pollution. As we know that the largest emission of the phthalic anhydride is come from the production facility of the phthalic anhydride. It comes from the reactors, vents, the product handling, and also during product storage. There is some related Environmental Act 1974. In section 21, there is power to specify the condition of the emission and discharge. In section 22, there is a restriction on the pollution of the atmosphere. So you know that this is the best way to control the air pollution by control it from its source point, and also the highly depends on the integrity of the manufacture team and also the management team, and on how to control the pollution. Okay, first we get the types of control device can be used, which is scrubber and also incinerator. As we know that incinerator has highly efficient and this is also easily to use. Incinerator has 99% of efficiency compared to the scrubber, which is about 86% of efficiency. Next, there is a pollution might come from the end products. As we know that phthalates are easy to migrate from the surface of the produced goods and then to the environment through leaching and the oxidation. As we know that the phthalates are harmful and also affect the soil properties, cause the infertility of soil, and also affect the human to breeding and other factors. There is some end products such as construction material, printing inks, varnish, latex, food packaging, and insecticide. As we know that this is not easy to control the pollution from the end products. This also is highly depends on the individual and also the manufacturing company on how to make sure that their product is safe to the consumer and also the environment.
So, as a conclusion, it is now proven that phthalic anhydride is one of the most important chemicals in the world as it contributes to many applications in our daily life. It varies from plastics to dye intermediates. Besides that, it also found out that the global phthalic anhydride market is expected to reach USD 9.1 billion by 2020, and it is also believed that it will increase more and more by year.
So that's all for me and my group. I hope you guys have a little insight on the production of phthalic anhydride. And if you guys do have any inquiries or questions regarding our processes, please do comment on the Google Classroom and we will answer your question. Thank you for listening to our videos. Bye.